Now we have seen different forms of dimensions of matrix. Okay, we can say that a matrix can be 2 by 2. Okay, and a matrix also, let's say it can be 3, or let's say 4 by 1, and it can also be 1 by 4. All right, so when we now say a matrix is equal to another matrix, all right, so let's take, for instance, we asked to give P. Okay, let's represent P to be a 2 by 3 matrix. So if P is a 2 by 3 matrix, definitely we are saying that the element, okay, remember in notation that the matrix itself is represented by bold capital letters, all right, and the elements are represented by small letters. So this will be P11. Since this is a 2 by 3 matrix, we know how that will be P12, P13, that's 2 rows and 3 columns, P22 and P33. Now if we have P to be a 2 by 3 matrix, and then we are at the same time given P or another matrix, okay, and we say that is equal to, let's say, 4, 6, 5, 1 minus 1, 3. 4, 6, 5, 1 minus 1, 3. Now if these two matrices are equal, okay, that means if we look at it now, the dimensions for this is simply 2 by 3, and the dimensions for this is simply, the dimension for this is simply 2 by 3, 2 rows, 3 columns. Okay, and the same thing applies here, 2 rows, 3 columns. All right, so that means yes, they are equal since their dimensions are of the same order, 2 by 3 and 2 by 3. Now the implication of that is that P1 will be equals to 4, P12, okay, P11 is equals to 4, P12 is equals to 6, P13 is equals to 5, and in the same vein, P21 is equals to 1, P22 is equals to -1, and P33 is equal to 3. Now let's write that out as plain as possible. P11 is equals to 4, P12 is equals to 6, P13 is equals to 5, and also P21 is equals to 1, P22 is equal to -1, and likewise P33 is equal to 3. Okay, so this, okay, that means the term we use here now is corresponding elements. Yes, corresponding elements. So by definition, two matrices are said to be equal if the corresponding elements are throughout are equal, right? So this matrix P is equal to this matrix, definitely their elements are equal. Let's consider another thing. So still on a 2 by 2, okay, let's move it now. We have been using 2 by 3. Let's change it to a 3 by 2 matrix. So that means we are saying that P11, okay, P3 by 2, that means 3 rows and 2 columns, and P12, P21, P22, P31, and P32. All right, now can we say that this is equal to what we have here, 4, 6, 5, and 1 minus 1, 3? Are they equal? All right, so let's look at it. Let's look at the order or the dimension in itself. We will look at the order of this matrix now. Is it has how many rows? 3 rows, and how many columns? 2 columns. So this is a 3 by 2 matrix. However, this matrix, it has 2 rows and it has 3 columns. That's a 2 by 3 matrix. So question, are they equal? No, they are not equal, because this order are not the same. So no, they are not equal. So two matrices are equal if they have the same order. Two matrices are equal if they have the same order. So now let's look at this final example. Let's use a 3 by 3 matrix, and this time we'll just use A, B, C, X, Y, Z, and P, Q, R. Yes. And if you say that this matrix is equal to 5 minus 7, 3, okay, 3, 2, 1, and minus 1, 2, 4. Okay, if they are equal, then we can have values of A, B, C, X, Y, Z, and PQR. Now you can pause the video right now and let's see what is A, what is B, what is C in the same vein, what is X, what is Y, and what is Z, and finally what is P, what is Q, and what is R. So A is equal to what, B is what, C is what, X is what, Y, Z, P, Q, and R. So pause the video and give it a try. So the answers are simply A is 5, B is minus 7, C is 3, X is 3, Y is 2, Z is 1, P is minus 1, 2, and 4. So it's simple. We just look at the values since they are equal. Okay, they are equal. So this is 3 by 3 matrix, and this is also a 3 by 3 matrix. So we just compare the values. A to be 5, B is minus 7, C is 3, okay, and X 3, Y 2, and Y and Z, sorry, 1, and P is minus 1, Q is 2, and this is 4. So we can see that represented here. So this is the joy of having equal matrices. That means they are of the same order, or rather say they are of the same dimension.